Okay, we've all been there, right? You write this beautiful piece of code, you're super proud of it, and then you come back 6 months later and it's this tangled, unreadable mess that's just impossible to update. Well, today we're going to dive into the secret weapon of basically every experienced developer, design patterns. Think of these as the blueprints that help us turn that spaghetti code into something elegant, something maintainable. Let's get into it.
You know what, this quote always makes me laugh, but it really hits home. It's not about becoming a code snob, not at all. It's about developing this kind of X-ray vision for software design. You start to see the hidden structure, or, the lack of structure, and you really begin to understand why some solutions are so robust and scalable, while others are just waiting to break. It's a total shift in how you see code.
So what exactly is a design pattern? This is super important. They are not snippets of code that you just copy and paste. Not at all. Think of them more like proven, reusable solutions to the common problems we all run into when we're designing software. They're a shared language, a vocabulary that helps us build better, stronger systems.
All right, here's what we're going to tackle. We're going to break down 4 really powerful patterns. We'll start with the strategy pattern for swapping out algorithms on the fly. Then, the template method, which is a really clever way to handle algorithms that are almost the same. After that, we'll hit the decorator pattern for adding new features without making a huge mess. And we'll wrap it up with the composite pattern, which is amazing for taming complex tree-like structures.
First up, the strategy pattern. This is your absolute go-to when you look at your code and you can spot a piece of it that changes or varies a lot. So instead of letting that chaos complicate your core logic, you just encapsulate it. You wall it off, making your whole system way more flexible.
Let's imagine a classic scenario. You're building a simple audio player. It handles MP3s, no problem. But then the business folks want FLAC support, then OGG, then M4V. And suddenly your once clean code is this monster if-else block. Every time a new format is requested, you have to go in and mess with that core logic, which is risky and makes the code so much harder to read. There has to be a better way, right?
And of course there is. The solution is the strategy pattern. Instead of having our audio player know the nitty-gritty details of every single loading algorithm, we define a common track loader interface. Each format, MP3, M4V, FLAC, gets its own little class that implements this interface. So now, the audio player just needs a track loader. It literally doesn't care which specific one it is. And here it is, the big payoff. Look at the before code on the left. That is a maintenance nightmare. Every new format means you're changing the central audio player logic. But the after code? Oh, it's beautiful. The audio player is completely decoupled. Want to add a new format? No problem. Just create a new class that implements track loader. You don't have to touch the audio player at all. This is the heart of the open/closed principle. Open for extension, but closed for modification.
So strategy is perfect for swapping out entire algorithms. But what if your algorithms aren't totally different? What if they share the exact same basic structure, but just differ in a few key steps? Well, that is where our next pattern, the template method, really shines.
So here's the problem it solves. You find yourself copying and pasting the same general method structure across a bunch of different classes, and you're only changing 1 or 2 lines inside it. This kind of duplication is like a ticking time bomb in your code. The moment you need to change that main algorithm, you have to go on a scavenger hunt to find and update it everywhere. Here's how it works. We define the overall algorithm, the skeleton, in one method, inside a base class. But for the parts that need to change, we define these abstract methods, or hooks. You can see them on the slide. They're basically just placeholders. Then our subclasses can come in and provide their own specific implementations for these hooks. They're effectively plugging in their unique behavior without ever touching the main algorithm structure.
The key takeaway here is all about separating concerns. The superclass is in charge of the overall flow, the what and when of the algorithm, but it defers the implementation details, the how, to its subclasses. This gives us the best of both worlds, a consistent, stable algorithm structure, with all the flexibility we need to vary the specific steps.
Okay, so far we've looked at patterns for managing algorithms. But what about when we need to add new responsibilities to our objects? I mean, we could use inheritance, but that can get really messy really fast. Let's explore a much more flexible alternative, the decorator pattern. Just imagine you're building a role-playing game. You have, say, 10 character races, elf, orc, you get the idea. Then you want to add 4 special abilities, stealth, super strength, and so on. If you try to create a new subclass for every single combination, like a stealthy, super strong elf, you'd wind up with 160 classes.
It's what we call a class explosion, and it's completely unmanageable.
The decorator pattern totally saves us here by favoring composition over inheritance. So instead of creating this rigid, massive class hierarchy, we simply wrap our base object, our elf, with decorator objects. Each wrapper adds one specific piece of functionality, and we can stack them on top of each other whenever we want, at runtime.
Let's trace this out, because it's pretty cool. We start with our basic elf character object. To give it super strength, we wrap it in a super strength decorator. Now we have a super strength object that contains an elf. Want to add stealth? Easy. We just wrap that entire thing in a stealth decorator. Now we have a stealth object, which contains a super strength object, which contains our original elf. It's like a set of Russian nesting dolls, where each doll adds a new layer of behavior. It's just incredibly dynamic. All right, our final pattern for today is the composite pattern. This one is all about dealing with those part-whole hierarchies, tree structures, and being able to treat both individual objects and whole groups of objects in exactly the same way.
Think about a file system on your computer. You have individual files, but you also have directories that can hold more files and more directories. Or think about an HTML document. You've got individual text nodes and then element nodes that contain other nodes. So how can you write code that doesn't have to care if it's operating on a single item or a whole branch of the tree?
The secret, the magic trick, is to create a single, unified interface that both the individual items and the groups can share. We call the individual items leaves, like our files, and we call the groups composites, like our directories. Both the file class and the directory class would implement the same component interface. And what this means is that our client code can treat a single file and an entire directory structure in the exact same way. That shared interface is everything.
And here's where it all comes together. When you want to do something like calculate the total size of a directory, you just call count size on that top-level directory object. That directory then just iterates through all of its children, calling count size on each one. If a child is a file, it just returns its size. If it's another directory, well, the process just repeats itself all the way down. This recursion happens seamlessly and your client code stays beautifully simple.
So we've walked through 4 really powerful patterns. But what's the big takeaway here? Why is learning this stuff so important for becoming a better software engineer? Ultimately, it's about moving from writing code that just works to writing code that lasts. These patterns aren't just clever tricks. They're fundamental principles for building flexible, maintainable systems. The strategy pattern lets us isolate things that change. The template method helps us reuse code without duplication. The decorator gives us flexible ways to extend features. And the composite pattern lets us build complex structures from simple pieces. These are the tools that let us manage complexity as our systems inevitably grow.
So, I'll leave you with this to think about. What problem are you wrestling with in your own code right now? That might just be a design pattern you haven't learned yet. Because the really beautiful thing is, the challenges we face in software design are rarely new. The solutions are already out there just waiting for us to discover them. Thanks for joining me.